Welcome to Surveying Codes. So we are discussing now in the unit 2, that is measurements and errors. So this is our lecture number 6. Here we'll be discussing the propagation of error. So basically in this unit 2 we are discussing about the error part and also measurement part, because in the surveying, as we have discussed earlier also, the main objective here is to prepare the plan or map, right? So for that, we are like this type of plan or map we have to make it. So for that, basically we have to take so many measurements on the field, right? So to find out what is the distance or what is the angles, right, what is the elevation, all these parameters you have to find it out on a field. So that comes actually measurement. So again, we have in the measurement, we have seen in the last earlier lectures that how to make the significant features, and what is the error part, what is the true value, what is the uncertain value, what is the reliable value. All these parameters we have seen in detail, and also how to round off the values, because in field the values will be in any float number, means something in a decimal point, the distance as well as the angles also. So now our objective, in the earlier classes we have seen that how we can make the values rounded off, and also uh, by removing this rounded off values, how we can compensate the errors. Then in earlier classes also we have seen the different types of errors, what are the source of errors, and how to deal with different types of errors. Okay, so in this lecture number 6, we'll be discussing about the propagation of error. Means when the error occurs on a single measurement, then how this error is propagated throughout the entire measurement. So that we'll be discussing in this lecture. So propagation of error. So measurements are used for calculation of different parameters. As the measurement are are having with the errors, it is important to know that how these errors combine in various mathematical operations. So for example, you want to find it out, what is the area of the entire land, area of this land, we want to find it out. So we went to with our tape or chain on a field, and we find what is the length here. So this length may be 5.289, and this meter, and this length may be 8.571 meter. So both the lengths we have find it out, okay, on field. So now we have seen in the earlier lecture also, so this in this number somewhere, so what will be the significant figure? So significant figure may be 5.28, and 9 is the uncertain value, means this 9 is basically the error part. So here this may be changing, right? So up to 5.28 is the significant digit, and last one maybe we can call it it is the error part. Similarly here also, now if you have to find out what is the area here, so area means we have to multiply this length by this length. So here we have a small error. So this length has an error of plus minus 1 millimeter. Maybe if it is in plus minus 0.01 meter. This is the accuracy for this scale. Similarly here also you have plus minus 0.01 meter. So values, so if multiple person is measuring the distance, both the distances, then there may be a maximum change in the values will be, maybe someone may get 8.572, like 0.01 maybe more. So this is the accuracy part, right? So this is the error part basically, and how this error propagates to the other measurements. For example, you want to find out what is the area. So area means you have to multiply this length by this length. So this length, this is the actual part, true value. Then we have the error part, plus minus 0.01. There may be a deviation in the value. Similarly here also, plus minus 0.01 is a deviation in the value. So what will be the net area here? And in the net area, how this error will be propagated, so that we'll be discussing in this lecture. Like in the when you do addition or subtraction or multiplication or division or any arithmetic operations we do with these numbers, how this error will be propagated from one unit to another unit, that we'll be discussing in this lecture in details. So let's get started. So here the error propagation in a sum or the difference of measurements, as I mentioned earlier also. For example, you have, this is one line, this is another line you measured, right? Now we want to find out what is the angle here. Maybe you already find it out what is the angle here. Now you find what is the area here, you want to find it out. Then you have this length value, you have this length value, and maybe you have this angle value, right? This three value you have. Now with these three value, you have to find out what is the area inside this triangular region. So now again, the error will be there in this measurement, error will be there in this measurement, as well as error will be there in the angle measurement also. So how this error will be propagated in the area part, that we'll be seeing. So here we are discussing error propagation in the sum, means when you are adding two values, right? For example, one line that is very big area, you want to find it out. Total line distance may be 5 kilometers, for example, right? So in that case, at one stretch you cannot find, because 5 kilometers is very long. Maybe we can make some intermediate point. So this is one point, this is another point, this is another point. So like that, at the middle we normally take some intermediate points. So from here, first we find out what is the distance here, then again we find out from here to here what is the distance here to here. Like that, we divide the entire long distance into multiple small distances, and from there basically we find out what is the distance of each segment. So that is basically we are adding the lengths, adding the measurements. So as we discussed earlier also, that each distance will be associated with the errors. So error also will be summing up, and how this error will be propagating, that will be seeing in this slide. So when the two or more quantities are added, like this quantity all are added or subtracted depending on the operations, the error in the result es is square root of the sum of the square of the errors. E1 E2 is the each error. So here this measurement you have E1 error, this measurement you have E2. Like that, if you have multiple errors in each measurement, then the net error E, so net error E in the total line will be plus minus root square E1 root square E1 square plus E2 square. So that is the equation for computing the errors. So we have the, if you have the error here, E1, let me write it here. So here you have E1 error, here you have E2 error measurement, here you have E3 error, E4. Then what will be the net error in the entire length? Capital E should be root square of E1 square plus E2 square plus E3 square plus E4 square, right? And this will be plus minus, because error may be positive or error may be negative. So in that range error will be lying. So that is the equation, that is the convention basically we follow while throughout the surveying course. So for example, at distance you have the 120 plus minus 2, means 120 is a significant number, significant value. Plus minus 2 means 2 means the error, means 2 meter there may be a error may come in the measurement, right? Each person, if they are measuring different value, then there may be a maximum plus minus 2 meter, means someone can have 122 meter or 118 meter. So in that range the distance will be, so plus minus 2 is the error, and this one 120 is the reliable number, plus 321 plus minus 5 meters. So these two numbers now, for example, these two length you want to measure, e1 plus e2, not e1 plus e2, but this distance plus distance, both the distance you want to find it out. So if you have to add this plus this, so the true part 120 plus 321 will be directly added. So 120 plus 321 will be 441. So 441 will directly come, plus minus error. So in that error we have to use this equation or this convention for the error propagation. So that's what we are seeing, how errors are propagated from the different measurements. Like, so here error is occurred in the single measurement E1, and here also another individual measurement we got error E2. Now how the error is propagated when we combine both the lengths, so that we are finding out here. So 441 plus minus of root square e1 square plus e2 square means 2 square plus 5 square, very simple here. So if you do the arithmetics, you will get 441 plus minus 5.385 mm. So you can see, in normal convention what we do, we can simply add it, right? E1 plus E2 is the error propagation. So E1 is 2 and E2 is 5. So 5 plus 2 7, like plus minus 7 millimeter error will be there, right? If you combine, that is normal convention, we can do it, but that is not we are following in this code. So here we are doing plus minus root square of error 1 plus error 2. So this you can see the error will be plus minus 5.38 meter mm. Okay, so that is how the error is propagated while we are taking the sum. And similarly, if you want to subtract the value, then also same process will follow. So this minus this will be there, a plus minus root square error square plus error square. So this is a normal practice what we follow in this surveying course. So now here we'll be discussing error propagation in a product of a measurement. So in earlier slide also I have given an example, like if you want to find it out the area of a triangle or maybe area of a rectangle, in that case also you have to multiply the two lengths. So this length multiplied by this length, you will get the entire area. So in that case also the error will be propagated. So each length, each distance measurement, we have errors. Errors may be in terms of 0.001 millimeter or 0.01 meter, whatever it may be. Similarly, both the distances have some error part associated with it. Now when we multiply both the errors, that also will be propagated in the next measurement, means area. So when the two or more quantities are multiplied, the errors in result is the square root of the sum of the square of the fractions error of the individual quantity. That means if you have an error of EA is the error in the A measurement. So you have the two measurement here. This is a total rectangular area. So in that, so this length you find it out. A is the significant number plus you have the error part. Error is EA. So this EA may be very small. Similarly here another measurement you did, that is B is the significant number plus error part is EB. Okay, so now the final error, how the error will be propagated from the distance to the area. This will be simply root square EA by A. So EA means the error in the A measurement by A. A is the actual measurement square plus similarly EB is the error in the B divided by B square and root over. So that is the product, that is the final product of this, maybe that is the final area of this region, that is AB multiplied by the error part. So that's how the error is propagated from one measurement to another measurement. Okay, so E and EB are the errors involved in the A and B respectively. Okay, so for example, a rectangular measurement, you have the measurement, this length may be for example 160.881 plus minus 0.026. 0.026 is the accuracy part, basically, where this much is the error part, basically, right? So, similarly another distance you have the 75.007 plus this much is the error part, so plus minus 0.001 wide. So now if you want to find it out area here, then the area will be, if you have to multiply 160.881 multiplied by 75.001, that will come to this value plus plus minus basically, this error part is what, 0.026 upon the entire value root square, the same formula we are using here. So this plus again this value will take, second one is 0.001 divided by the actual value or true value, that is 75.001. So if you compute, that will be the error part. So plus minus 1.9751 is the error part in this measurement. Okay, and similarly this is the actual part and this is the, if you multiply both, 160.881 is the significant numbers, if you multiply you'll get this one, root square of error part. So that's how the errors are propagated in the product of two numbers. So this is also very much important because multiplication will be doing it a lot while computing the areas or the volume of a landmass. Basically we do multiplication, so that's how we have to do it, while the significant and the error part, how it is propagated from each distance or each length to another area. So now the next topic here is, and how error propagates in the division. Division means like if you divide the total distance into a number of divisions, then we call it as division, right? When two or more quantities are divided, the error in a result is the same formula, right? Square root of the sum of the square of the fractional error in the individual quantity. That means the same formula here, but here in earlier we used to do it A into B in then root square of EA by A whole square plus EB by B whole square. Now here A by B, because we are doing the division, so here also the equation is A by B into this part is exactly same. So for example, here one example is given. If a area of a rectangular plot is somehow known to be, so area of a plot, right, for somehow earlier you have some document in that this area of maybe rectangular, this is not the random one, let me just draw a rectangular one. Okay, so now a rectangular plot you have already, and somehow you know what is the area. Okay, and you already find out what is the width here. Now you want to find out what is the length. So in that case, what will you do? You will area will be divided by the width, you will get the length. So that's how. So area is given to us, which is, this much is the area. Somehow, in that this part is the original digit and this portion is called the error part, right? So error part is this portion, whereas first portion is actually, this is actually the significant number. So now width also, width is given to us. This is the significant number, 175.6 is already you measured it, and you have the error part also. So error part is 0.46 meter. So now the calculated length, you have to find it out. So in that case, how will you do it? You have to divide the area divided by the width. So area divided by area is 4.650. The area is, 49650 divided by this 175.66 into error part. So error part will be how much? This is the expression, right? So ea is the how much error? Error here is 10 by total value, right? Total value is 49650 square plus in the eb reading or second reading you have the error 0.46 divided by the entire area divided by the entire eb, entire length. Eb is basically 175.66, square it, and then you will get this is the final value. So that's how the actual computation does, and we can see how the errors are propagated from one reading to another reading, and this is for the division, very similar to multiplication what we did in the earlier. So now the last part here is how error propagates due to the power of a measured quantity. Right now, in the power, like 2 to the power 3, 2 to the power 5, in that case, or any numbers, square, cube, to the power 4, to the power 5, how in the power, basically errors are propagated. That we'll be seeing. So the error in a physical quantity raised to the power is the power times the fractional error in the individual quantity. For example, you have a measurement of some measurement, you have a, so let me write it here. So you have some measurement a, another length measurement b, another length measurement c. So you have three measurement. Now you want to compute some parameter. So in that parameter, maybe some random value you want to compute, some value you want to compute, and that value should be, a to the power p, you have to do it, b to the power q, you have to do it, and c to the power r, you have to do it. So in that case, how the error will be propagated in the power, that we are seeing here, and this is the formula for that. So error in power, basically plus minus the value which you want to compute, then root square of p into p means in a is a to the power p, right? That's why p into ea means error in the a reading by a square, plus similarly b reading, what is the power of b? It is q, right? That's why q multiplied by EB is the error in the B reading by the original B reading square. Plus similarly the third part, that is C. See here it is in division, but still we are adding it everything in the error part if you see. So here also c to the power r, so it's r into ec is the error in the reading c divided by c square. So that's how the error is computed while we are computing the power. For example, you want to compute, as I mentioned here, like some computation z equal to ap, bq, and cq, you want to find it out. In that case, the error will be plus minus this value into root square of the same whatever we have discussed earlier, right? Means a to the power p means p into delta a. Delta means the error in a by original a square, plus similarly q into original key q square, something we can do it. Now, so this is the example it is given. If a spare's radius is given to us 10 plus minus 0.08 meters, so if it is a spare, you can imagine, and the radius is given to us. If you want to find it out, the volume, the calculated volume is this much, and the error will be how much? So the volume will be this much, right? We can compute it 3 pi by 4 into r cube, right? 3 pi by 4 into radius cube is the volume, and how much will be the error in that reading in the volume, how much will be the error, that is the question. So error part in the radius measurement is 0.08 meter. So 0.08 meter is the error in the radius measurement, but what will be the error in the volume measurement? So the same formula here, we have to use the cube formula, right? So plus minus pi by 4 pi by 3 into 10 cube root square 3 means why? Because here it is cube, right? That's why cube 3 is multiplied 3 into how much is the error in the radius reading? It is 0.08 by total original value is 10 square, and this is the error in the radius. So error in the radius measurement is 0.08, whereas error in the volume calculation will be 58 meter cube. Okay, so that's how we have to compute, and we can see now the how errors are propagated from one measurement to another measurement. So this is the exercise for you. You can do it and you can submit it. Plus, please. So here is a question here. So first exercise is the two sides and the included angle of a triangle are observed as under. So A equal to this value is given, B equal to this value, and angle C equal to this one. Compute the area of the triangle and the probable error associated with it. So here the question is what? So basically you have a triangle. So you have a triangle, something like that, and this length is A. A is given to us. So A also is given is how much? 254.26 plus minus 0.25 meter. And this length is B. So both you have measured it on a field A and B, and both value you know. And the C included angle is also given to us. C included angle means this one is included angle, right? This is C. This is also given to us. Now you are supposed to find it out the area under this area under this triangle, right? And also the error associated with it. And what will be the error? Because A measurement you have the error of 0.25 meter, B measurement you have the error of 0.30 meter, and C, that is angle measurement, also you have the 20-second error. Okay, so now is that's what we have to find out. So make sure that C is given in the second. So you have to convert it accordingly. If you are doing it, then you have to convert it into degree and all. Anyway, so you have to find it. This is first exercise you have to do it. Now what is the formula for finding out? I am giving you hints. So the formula for this will be how much? So the area for this triangle will be A into B sine C. Right, simple. Earlier we have studied in the school days geometry class, we have studied this one equation. So the area of this triangle will be A into B into sine C by 2. Right, so that you can do it, right? Simply half into base into height, right? That is the equation for the triangle. You can easily also compute it. So this angle, this length is given A, and this entire length is given B, and this angle is theta. Then what will be the area? So area of this triangle is always half into base into height, right? So height, compute what is the height and what is the base also, right? So with the sine theta you can easily do it, and for that you will get this is the area for that. So just substitute all the values, and also the error part we have discussed earlier, also how errors are propagated in the multiplication. So here A and B basically we are multiplying it, so please check it, the equations and we have used for the multiplication, and then you compute, and this is the answer. You check whether you get the similar value or not. Similarly, this is another problem. An angle is measured with a standard deviation of plus minus 2 seconds. So for the find the most probable error and the maximum error in the observation. So already we have measured the angle. For example, this triangular area you want to do the surveying. So for that you already measured what is the angle. So the standard deviation or the error part basically is given plus minus 2 seconds. So you have to find out what is the most probable error and the maximum error in the observation. So please read the error part as much as possible and try to solve both the problems, and the answer is also given to us. So in this lecture, basically what we have seen is actually how errors are propagated from one measurement to another measurement. We have seen how errors are propagated in this in the addition and the subtraction also, and then we have seen in the multiplication and division, as well as in the last slide we have seen the how if you want to do a power calculation, then how errors are propagated in the power power operation also. So that concludes this lecture. Thank you.